Hey guys, welcome to your Unit 9, Lesson 4 notes on solving quadratic equations by factoring. The day has come. Factoring is important. Remember when you start out with something and you have to end up with like x plus 5 times x minus 2 or whatever. We're doing that. That's important today. Yay, I'm so excited. In fact, by the end of the day, you'll be able to solve quadratic equations using factoring, and the zero product property. You guys, the zero product property is one of my favorite things in the history of all things ever. Here's why. All right, I'm thinking of a number, okay, and when you multiply it by 5, it's equal to 0. What is that number? You're right, it's 0, because 0 times 5 is 0. Okay, good. All right, I'm thinking of another number. And when you multiply this number by 18, it's 0. You're right, it's 0 again. Because 0 times 18 is 0. Okay, last one. I'm thinking of a number. And when you multiply it by negative 2/3, it's 0. Yeah, got it. Shooties magooties, man. It's still 0. Because guess what, guys? No matter what, this could be literally any number. Any number times something equals 0, it has to be 0. One of those numbers has to be 0. And that's what the zero product property says. It says, hey, for all numbers a and b, if you have a times b equal to 0, then either a equals 0 or b equals 0. Or both. It could be that a and b are both equal to 0, and that's fine as well. This is your key idea. Know it, love it. We're going to use it today. And why is this important? Well, if you have this equation right here, and you know that 3x times x minus 1 equals 0, you know that either 3x equals 0 or x minus 1 equals 0. Because it has to be, one of these has to be 0. So now we're going to solve, well, what has to be the case? What does x have to be to make this true? If 3x is equal to 0, what is x? Well, we'll divide by 3. 3 divided by 3 is x. Okay, sweet. 0 divided by 3 is 0. So x is 0. Sweet. Or if x minus 1 is 0, well, let's add 1 to both sides. Okay, x equals 1. There you go. X is 0 or x is 1. Now we need to check. We check, remember, by plugging x. Oops, sorry. I want to get rid of this color coding because that's the wrong color coding scheme to be using. Okay, know that either x equals 0 or x equals 1. Well, let's plug it in and see what we get. I want to use gray today. Pink. Okay. So we know 3x times x minus 1 equals 0. And we're going to check if both of these makes it work. So is this true? Is it true that 3 times 0 times 0 minus 1 equals 0? Well, yeah, because 3 times 0 is 0, and 0 times negative 1 is 0. So, yeah, that's true. Oh, I was supposed to make that gray because we're checking our work. Man, look at me go. Bink, 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 done. Okay, yeah, that's true. Okay, well, what happens if... oh, yeah, we're checking our work. This is great. If x is 1, will that make this 0? Well, we have 3 times 1. 1 minus 1, is that equal to 0? I don't know. Let's see. That's a question mark. Is it equal to 0? Okay. 3 times 1 is 3 times 0 is 0. Yeah, we did right. Cool. So using the zero product property means splitting it up so that each one of these is equal to 0. So what are we going to do here? Well, let's split it up and make each one of these equal to 0. First, we'll say a minus 2 is equal to 0. And then we'll say that a plus 5 is equal to 0. Because if they multiply to 0, one of them has to be 0. Or they can both be 0. That's cool too. Sharing is caring. Okay, so to get a all by himself, we add 2 to both sides, giving us a equals 2. And here to solve for a, we're going to add 5 to both sides, giving us a equals, nope, we're not going to add. We're going to subtract 5 from both sides, giving us a equals negative 5. Again, check your work. Is it true that 2 minus 2 times 2 plus 5 is equal to 0? Well, 0 times 7 is 0. So yes. Is it also true that negative 5 minus 2 times negative 5 plus 5, is that equal to 0? Well, negative 7 times 0 is still 0. So that's correct. So if you want to leave your answers in 2 circles like that, that's fine. You can also totally say, hey, a equals 2 and negative 5. But I like to put them, from smallest to biggest. So a equals negative 5 and 2. So that's cool too. No, 2. When are we going to use this in real life, Ms. Van Dyke? Well, let me tell you right now. First, you read the equation, and the question, and you say, Chris builds a rocket. You can take some time right now and draw a really cool rocket. I'm not going to. He finds he can model the rocket's height in feet after t seconds using this equation. How many seconds will it take for Isaac's rocket to touch down? Well, I don't know who Isaac is, but this is Chris's rocket. So Chris's, rocket. Okay. Well, touchdown means, so you've got this rocket. Remember when I said I wasn't going to draw it? I'm going to draw it now. So this dot represents a rocket. Okay. And the rocket goes up high in the sky, and then it goes down like that, and then touchdown is where it touches down, where it touches the ground. Okay, so we're looking for, what is that point right there? What is t equal? How much time has passed? How much time rather has passed? So we want to find out, when does this equal 0? When does 48t minus 6t squared equal 0? What does t have to be? Well, first let's factor it. Let's simplify this as much as we can. I notice they both have a t in common. So I'm going to factor out that t. They also have a 6 in common, so I'm going to factor out a 6 as well. So we took out their GCF of 6t. And we're left with, we got rid of a t, didn't we? So we're left with 8 minus t. Oh, is that it? Wow, that was way simple. I made this way too big. But that's okay. So we factored that side, and then we scooted way up on the paper for absolutely no reason. That's equal to 0. Okay, cool. So after factoring out a 6t from both of these guys, now we can solve this using our zero product property. So we're going to split it up, and we'll say, well, what happens when 6t equals 0 and when 8 minus t equals 0? Well, here that's pretty straightforward. We just divide by 6 on both sides, giving us t equals 0. And that makes sense, right? Right when you launch the rocket, it's at the ground. That's what this point is right here. But that's not what we care about. We care about how long did it take for him to come back. And that's going to be solved by this side. So first I'm going to add t to both sides, giving me that 8 equals t. And then I realize, oh, I'm done. 8 seconds. So it took 8 seconds for Chris's rocket to touch down. So 8 seconds. Which seems kind of fast for me. But cool. Okay, we got 2 more. Well, that looks gross. There are 2 things that this needs to happen. First, we need to, I don't have any good colors here. Okay. First we need to set it equal to 0. And then we need to factor. Right now it's equal to 3. And the way we get rid of that 3 is we just subtract 3 from both sides. So we get x squared minus 2x minus 3 equals 3 minus 3, which is 0. Sweet. And now we need to factor this guy. Remember factoring? And you have to figure out, okay, well, what's going to get x squared adds up to negative 2x and multiplies to negative 3? I should have made this gray. I'm sorry. We're showing work. So if you want to show work like this, that's great. If you want to just say, hey, we need two numbers that multiply to negative 3 and add to negative 2. Well, that has to be negative 3 and 1, giving us an x, a negative 3x, and that's a negative 2x. Sweet. So that tells us that our factors are x minus 3 and x minus 1. Now if our trinomial is equal to x minus 3 times x minus 1, then that must be equal to 0. And now we can solve it using our zero product property. So we split it up and we said, well, what if x equals 3 was equal to 0? And then what if x minus 1 were equal to 0? What would that have to be? So you remember to add 3 to both sides, and that tells you, hey, x equals 3. And then you'd say, oh, okay, well, wait a second, I did something wrong. X minus 3, x plus 1. Okay, sorry. This is an x plus 1. X minus 3, x plus 1. X minus 3, x plus 1. Okay, sweet. Back over here, well, we need to subtract 1 on both sides. And that says x equals negative 1. Whoa, that's like broken deja vu. Because we were looking for, the numbers we were looking for were negative 3 and 1. And now we found their opposites, 3 and negative 1. Isn't that funky? That's also no accident. But anyway, this is our solution right here. X equals 3 and x equals negative 1. Now, how do we know that's true? We have to check it and plug it back into our original equation. I'm going to run out of space, though, so I'm going to kind of like do it twice. So here, what if x were 3? Is it true that 3 squared minus 2 times 3 minus 3 is equal to 0? 9 minus 6 minus 3 is 0. Cool. What about negative 1? It's negative 1 squared minus 2 times negative 1 minus 3. Is that 0? Well, is 1 plus 2 minus 3 0? It is. Sweet, sweet, right. Cool, that's great now, but we're not going to use this in real life. Well, let's say that our friend Jojo is blowing up a photo for an art project. And by blowing up, I don't mean like exploding, but she's got a little photo and it's like 2 inches by 3 inches. And she needs to make it 5 times bigger. So she needs to take this and then, ooh, watch this fun trick. I used to not be able to do this. Thanks, Notability. She needs to take it and then whee, so it's 5 times bigger. Yoink. What are the dimensions of the new photo? Well, I don't know. Let's find out. Let's say this area is whatever the original area was. And then this new area, well, that's going to be 5 times bigger, you say? 5 times the new area. Okay, but guys, we know what this area is. The area inside of here, 2 times 3 is 6. So this area needs to be 5 times 6, which is 30. Okay, cool. But we don't know these dimensions. But we do know that we added the same distance. pretend those are the same size. We know we added x and we added x. So that means this is x plus 2 and this is x plus 3. So to find the area of this guy, I'm going to get rid of this because now this is just kind of extra work. This is 30 inside. Okay, so we know this rectangle is 30, and we know its side lengths are x plus 3 and x plus 2. What is x? Well, we can solve this by factoring. Watch this out. First, we need to FOIL it. We need to do our first outside, inside, last, giving us x squared plus 3x plus 2x is 5x plus 3 times 2 is 6. Now we need to make everything equal to 0, so we're going to subtract 30 from both sides. So 0 is x squared plus 5x minus 24. Okay, sweet. Now, to factor this guy, we're looking for two numbers that multiply to negative 24 and add to 5. If you want to go into your box, you can, but that'll end up telling you that you need to find positive 8 and negative 3. So 0 equals x plus 8 and x minus 3. Man, when are we going to use factoring in real life? Oh, we just did. Okay, zooming back in. Now we know that's equal to 0. So either x plus 8 equals 0 or x minus 3 equals 0. Well, on this side, we get x equals negative 8. But that doesn't make sense because you can't add negative 8 inches to something. That's like sending it into the void. It's like subtracting 8. No, it's like negative 6 length. Doesn't make sense. So that's a non-viable solution. It doesn't make sense. That doesn't work. Well, let's hope the other side does. I'm going to add 3 to both sides, and that gives us that x equals 3. Oh, that makes a lot more sense. Okay, sweet. So that means that's now 5 by 6. And that is 30. Sweet. Cool. Weird dimensions for a photo, but hey, it works. So remember zero product property. If you have things multiplied together and that equals 0, then one of them has to be 0. But see what happens to make them all 0. Have a great time on your homework.